A very good day to my beloved lecturer, Miss Anyiki, and we're gonna present to you our final project. I'm Wong and my teammate is Kaman. We are from FCM1. The poem that we chosen is The Twilight Waves. This poem inspired us to want to make something that is about the light waves. And our project title is Tides of Twilight. The Tides of Twilight is a series of generative visual works and, of course, combined with the interactive elements and audio reactive elements, we are inspired by the poem Ombak Senja, which is the twilight waves. Each piece explores different forms of waves, from ocean tides and light frequencies to emotion, rhythms, and human interaction. The work reflects the feeling of twilight as a transitional space, a moment where light fades, stories surface, and movement softens. Across four parts, sea waves, light waves, interactive waterfall, and rhythm reactive visuals, this project captures the gentle tension between the resonant energy, reality and dream, stillness and flow. Blending digital art with poetic emotion, Tides of Twilight invites viewers to experience waves not just as emotion, but as memory, feeling, and transformation. This is our artist statement.
This is our photo reference 1 and 2.
Next, the reference tree is referred to the waterfall. When the obstacle is between the waterfall, then it will create a feeling that like a light wave. Into the reference 4, we wanted to create something that is a light waves in the universe. And the next is our tutorial's reference. Our reference 1 and reference 2 is referred to supermarket salads video. And our reference 3 is from the Red Notes, and the video is by Henry Shen. The reference 4 is also from the supermarket salads video.
And now this is a tree image for our first visual work. The ideas came from natural things like wave, smoke. And I chose soft purples and white colors to make it look calm and dreamy. And this is the design progress for our first visual work. For the first, I used a constant chalk to set up the simulation resolution as 1280, and I used a RAM 1 and 2 to create the gradients textures. Second, I used a reorder to rearrange RGB channels into XYZ vector. After that, I used a point transform to wrap image based on the vector field. And then I use a null for the final output node. Overall, this node chain create a vector field using gradients wrap, then use that field distort or wrap an image through point transformation. It is a common setup for field like effects or UV displacement in Touch Designer. And for the next part, I use a constant to set the resolution value, and I use a RAM 1 and 2 to make gradients image. And for the reorder, that turns gradients into vector field. Then I use a point transform wrap image using the vector field. And for now, it is for the final output. Overall, the final output is a distort image or texture wrapped by the vector field created from the gradients. It look like a file or flow like motion effect show through now 1. And from the next part, I just use 3 chop, what is keyboard 1, feedback loop, and particle system. And then the final visual output comes from transform 1, which combines particle from particles GPU, feedback visual from feedback 1 loop, all processed through over 1 and transformed from style, position, and transform 1. And now this is the tree photo for our second visual work, and it looks like a light wave. So this is the chop that I use, and for the final output, a whole noise value from hold 1 in speed to change from speed 1, a key press count from count 1. These are combined in now 1 and now 2 ready to drive animation parameters or visuals. And for the next page, this is a network that create animate point with motion trails. For the first, the start and feedback chop, continuous trail, and the noise to random movement. And from the point transform 1 is abless movement, and from the level 1 is control, fade and brightness. After that we have a pause. This is the final visual output. For the final output is the pause top, which display a visual movement particles with trails driven by noise and feedback. And now this is the next page for our progress. For the final output, feedback chop 1, which show a growing animate trail of 3D particles or point, enhanced with feedback, blur, noise, and displacement effect.
And here we got 3 images from the final work. You can see that there's a hole here, which my hand is like the obstacle, and it did have the shape of a waves. Okay, let me explain you to my design process. It is a waterfall like waves, and when a hand is detected by the hand tracking, the waterfall will be blocked accordingly and follow the movement. The camera and hand tracking, yeah, this too, is from the media pipe and mostly completing using the soap and top. The design process for the opening, we're using soap. The media pipe and hand tracking is set up here, and the grid soap serves as the base. The sword controls the order of a point, and the particle soap is used to generate the particle effect. Point soap used to manipulate points like scale. The trash, trace, extrude are used in the hand tracking process to enhance the performance and visual quality of a particle system. Transform soap is to control the position of a hand. The next one, let me go to the middle. The particle soap already set the particles type as a render as a point sprite. So drag the point sprite map to the gel soap. Can show the color that adjusts in the RAM top. And we did set a camera here, so we can just easily adjust the angle that we wanted to present. Let me go to the next one. This is, we did add the render, feedback, blur, level, and composite. And we did have some adjustment in the blur and level. Also, the bloom, you create a glow effect for the final work. This work is auto-reactive visual works, so this thing's particles will follow the music flow. Let me explain the design process. It is a light waves in universe and it is auto-reactive work, and it needs the combination of a chop, soap, comb, and top. First, I'm gonna explain for the audio. The audio file in chop is used, and there's a delay. It allows the particle movement or response in more dynamic way. And we did have create 8 audio filter chop, and the filter cutoff and each parameter is set into different hertz in ascending order. And we got a merge and also shuffle here. And this one is an explanation for the particles. Select chop is connected to the chop 2 here. So for the transformation of a signal to the next processing stage, the particle soap, we got chain 1, chain R, and chain channel. They can be used for physical attributes like the particle's position or velocity, while the chain R channel can control visual. Later this I will show you in the explanation. There are two particle soap and they present different size of a particle respectively. The size of a particle is bigger in a particle 1, while the size in a particle 2 is kind of smaller. As you can see in the final work, there's a small particle in the middle that is in a deep pink color. The torus soap can guide the particles move along a circular path, and there I got two camera here for the selection, so I can choose what I want to present at the end. And the next one, it is not particle, it's adjustment, and I will correct it later. The render 1 connected to both camera while render 2 only connected to the camera 2. So it is different things they present. The camera 1 is quite clean and clear. However, the cam 2 is quite glowy and bright. I will show in the explanation later. In anti-aliasing top, it is set to the ultra, so the quality of the render image is more smooth. To the feedback edge, it is from the left palette and enable to connect to composite top as it can achieve a dreamy aerial visual effect. And the last one, the bloom top, it is added so I can make a glowy effect. And that's all from our presentation slide. And next, we're going to explain the network.
This is our final project, and we use a template that provided by our lecturer. To present my work, I can use the number keys 1 to 4 on the keyboard. Each key will show a different work file. We started to build all the networks in a single file to keep the things organized and consistent. Once everything was done, we copied each network into its respective base file. This helped us avoid repeating the same steps and made it easier to manage. We also divided our work between us. Gaman was in charge of work file 1 and 2, while I focused on the work file 3 and 4. We communicate throughout the process to make sure everything matches and works smoothly. This is the first work file and the second work file. The third work file is waterfall waves. The last work file, it is an audio reactive work file.
And now let me explain to you the third work. Actually, the video that I referenced to, they are not using the media pipe and this hand tracking. They are using the Kinect, which is this one, as a camera. So I just changed it to media pipe. Okay, let's talk about the grid first. The grid salt, which is this one, serves as the base geometry of the water surface. It allows the deformation when the hand interaction is detected. Next, the sort soap is added. We set the point sort into random as the orientation of the particle will be random. The next one is particle, the most important things in the work, because it can generate the particle effect, and from the particle, we can adjust the external force.
By setting the y-axis values to negative, we allow the particles to simulate falling motion. We also adjust the time settings to make the particle flow faster. Next, to create a waterfall-like effect, we increase the turbulence. We increase the burst rate to make the particle density higher. Then we adjusted the life expect to extend the visibility duration of each particle on the screen. Next, we increase the drag value so that the particles move more slowly, creating a softer and smoother motion. This helps to simulate natural flowing behavior. In the state settings, we change the particle type to render as point sprite. A point stop is connected to the particle system, and we increase the scale to enlarge the particles. After that, the gel comb is connected to the point stop, and the point sprite top is added and dragged into the gel comb. We use a ramp top to control the color of the particles. It's connected to the point sprite so that the particles appears in the blue color, which I selected. Then we added the camera comb and light comb to the network. This allows the particles to be viewed in 3 dimensions. Finally, we go back to the front part of the network. We did added trash, trays, and extrude tops to enhance the overall shape and motion of the particle effect. For the extrude soap, you can see my hand here. The hand tracking system is used to enlarge the hand shape captured on the screen. This is followed by the connection to the transform soap, where I adjust the z-axis translation to reposition the hand mark. The hand shape needs to be placed in front of the particle effect so it can act as an obstacle to block or interrupt the particle flow. After that, the render top is connected to a series of components like feedback, blur, level, and composite. The level top is used to increase the brightness and opacity of the particles. The blur top helps to soften the edges of the particles and creates a smooth, flowing visual effect, which adds a sense of motion and fluidity. After the composite top, we connect a bloom top. This adds a glowy and dreamy effect, making the visuals appear more vibrant and magical. Finally, everything is connected to the null top, which is then set as the output. And that's all for the explanation of the third work file. Now let's move on to the fourth work file. Since it contains audio, I will mute it for now. First and foremost, we create the audio network. We start by adding an audio file in chop and audio device out chop. Next, we bring in a rename chop and connect it to the audio file in. After that, we add a delay chop, which allows the particle movement to respond more naturally and dynamically to the rhythm and changes in the audio. Next, we created 8 audio filter chops, each with different filter cutoff values. These audio filters are used to isolate specific frequency ranges, such as low, mid, and high, from the audio signal. This helps create unique particle responses based on the energy in various frequency bands. As you can see, the cutoff values are set in ascending order, for example 40, 120, 1200, 2200, 3200, and so on. This gradual increase helps to split the audio spectrum into multiple distinct bands. We then use a merge chop to combine all the filter signals into a single data stream. After that, a shuffle chop is connected to the merge chop. This reorders the channels and makes it easier to process the filter audio efficiently, ensuring each frequency band is handled in a proper sequence. A null chop and select chop are added after that. The select chop is connected to a chop tool, which allows the audio signal to be transformed into geometry or positional data for the next processing stage. In the parameters, we define that P0 to specify the position channel and 0 to define the normal channel. While this setup allows us to target and manipulate specific audio data for driving the particle system behavior. Besides that, in the chop 2, we have 2 channels, which is Chan and Chan R, while the Chan R channel is used to control visual attributes such as the color, size, and brightness. Moving on to the particle soap, we made several adjustments to fine-tune the particle behavior. While these include mass, drag, birth rate, life expectancy, life variance, and also alpha speed. These parameters help define how the particles are generated, how long they stay visible, and how they behave while on screen. After that, we brought in a torus saw, which serves as a guide shape. This allows the particles to move along a circular path. Then we also added a transform soap to manipulate the position, rotation, and scale of a torus, giving us a better control over its placement in 3D space. Then we introduce a second particle saw. The settings we adjust here are similar to those in the first one, like mass, drag, life, and so on, but this time we scale everything down. This is to create a denser, more layered particle system, resulting in a more complex and dynamic visual effect. Next, a constant math is connected to the geocom to control the color of the particles. Next, we connected each geo to its respective particle soap. The geo acts as a geometry container for the particles, allowing us to display them in 3D space. In the setup, Geo 1 has a larger scale compared to Geo 2, which helps create depth and variation in the particle composition. After that, we added 2 camera comp. We just adjust their FOV angles to ensure the particles are framed well on the screen. For camera 1, we also set it to rotate smoothly over time, adding motion and depth to the scene. We then brought in 2 render stops. Render 1 is connected to the both cameras, while render 2 is connected only to the camera 2. Using these 2 cameras allow us to blend 2 different particle systems into one, resulting in a more complex and layered visual composition. Following that, we added an anti-aliasing top and we set it to ultra. This step helps us to smooth out the jagged edges and give the render image a high-quality, polished appearance. To enhance the visual atmosphere, we drag a feedback edge from the left palette and connected it to the composite top. This creates a dreamy, ethereal effect. Next, we use a bloom top to enhance the contrast and glow of the particles, making them appear more vivid and luminous. A constant top was also created to serve as a black background. It is connected to an overtop along with the bloom output layering the particles nicely over the background to form the final visual output. Lastly, everything is connected to an altar, which is set as the final output. Well, thank you. Thank you very much and appreciate that for lending your ears to us for our presentation. Have a nice day. That's all for our presentation. Okay, then that's the end of the fourth work file, and it's come to the end of our presentation. Thank you very much and appreciate it for lending your ears to us. And have a good day.